Hello friends, welcome to our website automationcommunity.com. Today we are going to see another interesting example, which is recipe control using PLC and HMI. So let us see in detail description of our project. First of all, as you can see, I have created one HMI screen where you can see there are the three bins for three raw materials A, B, C, okay? And it has three solenoid valves, and here is our main tank in which we want to create our batch. So as you can see, first of all, here is the on off button. When you press this, process will start and off. So if the process is start, it will appear like this. Based on the recipe, respective valves will open and mixing will continuously mix the incoming material. Similarly, once if the batch is completed, you can press reset button to start another batch. Okay, here you can see timing values, because here the batching process we have considered the timing. That means in the recipe we are controlling the material based on the timing values. We will on off each solenoid valve based on the timing. So when you will click on the recipe button, this kind of screen will open. So you can see in this project we have created two HMI screens for a single project. So if I click on this button, this screen will open, and if I click on this home button, then again this screen will open. So these things we will learn in the next part of this video in the HMI programming. Right now, when you will open the recipe page, what will happen? You can see we have to enter the data for material A, B and C, and finally you can save this recipe. But what data we are going to insert in these numeric entries? So here I have written these two data are the first on off time, that means at which time this solenoid valve will become on, and then again at which time it will become off. For example, if I write 5 over here and 10 over here, that means it will start at 5 seconds and stop at the 10 seconds. So here you can see this is the running timing of the batch that I have displayed over here. Similarly, after that it should operate at the 20th second, and at 25th second it should be off. So in this way, for each material we can write three on off times that I have shown from here. First on off time, second time, and this is the third time. So similarly, for each material we can enter this data. So at some places it is based on time, and at some places it is based on weight. Okay, and at some other places load sensors are used to determine the weight, and based on the weight this process is happening. Here we have assumed one thing, that our total batch timing is 60 seconds. So this batch is completed in 60 seconds that we have assumed over here. So these timing values are going to be less than 60 seconds only. Now we will see the input wiring required for this project. As you can see from here, we can control everything from HMI screen only, but if you want, we can have physical on off button and physical reset button. So that you can see from here, physical on off and physical reset button, and recipe. So recipe can be controlled through HMI only. So for that, here we have connected HMI with our PLC. So here you can see this is the communication port 1, this is communication port 3, and below this PLC there is COM port 2. So by using RS485 or RS232 cable, we can connect our HMI with our PLC. Similarly, we will understand the digital inputs for our buttons. So first of all, in the source sink, we will connect the ground of our SMPS. After that, we will take 24-volt supply and then connect it to each terminal off button. Another terminal of on off button we will connect it to X0, and another terminal of reset button we will connect it to X1. So we have to remember this addressing. So these are our digital inputs. Now we will see the output wiring required. So from the HMI screen, you can see there are 4 outputs, this mixing motor and 3 solenoid valves. So here also we will connect one motor and 3 solenoid valves. So let us understand the output wiring of this PLC. So first of all, in the C0, that is the common, we will connect the ground terminal of our SMPS. Now at the Y0, this output I will connect it to one terminal of my relay, and another terminal of relay is connected to 24-volt supply. So if Y0 is on, ground will be provided from here and this relay will be on. If this relay is on, then in the common we have connected 230-volt supply, and at the NO terminal of this relay we have connected contactors one terminal and its another terminal is connected to neutral. So if the relay is operated, this common and NO terminal will close and it will give power to contactor, and contactor will start the motor. Similarly here, SV1 means solenoid valve for material A. Similarly, second solenoid valve for material B and material C. So each one terminal is connected to 24-volt supply and other terminals are connected to respective digital outputs Y1, Y2 and Y3. It is simple to understand. Now this is the in detail wiring of motor. Motor is operated through dual starter, that is MCB and OLR. So MPCB works as MCB and OLR. After that, contactor, and from contactor to motor. And this contactor is operated from this relay. Now we will understand the logic required to create this project. So here are the first 3 steps. When the start button is pressed, so these 3 things must be happen. So what are these things? First of all, as soon as the start button is pressed, mixing motor should start, or mixing motor should be on. It will always on when the start button is pressed. After that, as soon as the start button is pressed, 1-second pulses will be given to counter using a special register of Delta PLC. So the counter value will increase. And what is the third thing? As soon as the start button is pressed, this instruction should be started. This is the main instruction of our project. Its name is ABSD, Absolute Drum Sequencer Instruction. In the previous project of traffic light, we have used INCD instruction, which is Incremental Drum Sequence Instruction, and here we have used Absolute Drum Sequence Instruction. So by using this instruction, what will happen? In this, we will write our data, that is our recipe. Based on our data, it will compare the value of counter with our data, and based on that, it will on off different internal relays. Okay. So that data about the recipe, which will be taken from HMI screen only. So in the programming, we will not write this data. We will just write the address of this data in this instruction. We will write a code, that is, if internal relay M0 or M1 or M2 is on, then solenoid valve for material A will be on. Now why only 3 relays? So again, let's come to here. As you can see from this HMI screen, we have taken 3 on-off times. So this, if this period is running right now, for example, this is 10 to 20 seconds. So in this timer, if this is running between 10 to 20 seconds, this means this value is operated. That means here this relay will be operated, and so this valve should be operated. So in this way, because we have used 3 on-off times, so 3 relays will be operated for each material. So here we have used 3 relays for each material. So from M0 to M2, this is used for material A solenoid valve. Similarly, if M3 or M4 or M5 is on, then solenoid valve 2 for material B will be on. Similarly, if M6 or M7 or M8 is on, then solenoid valve 3 for material C will be on. So this is the logic. These things will be clear to you more while doing the ladder programming. So let us start our ladder programming. So friends, now I will open my ISPsoft software from here. Let us click on the new file. Yes. So we will write the name of our project and click OK. As usual, first of all, we will write the device command list. 0 is our main on-off button. X1 is our reset button. Then click on Y for outputs. So Y0 was our motor as per our diagram in PPT. Y1 is our solenoid valve 1 for material A. Y2 is our solenoid valve 2 for material B, and Y3 is solenoid valve 3 for material C. Okay. Now click on M for internal relays. So we have used 9 internal relay. So M0 is first on for material A. M1 is second on for material A, second on time, okay, for material A. And M2 is the third on command for material A. So similarly, we will write for material B and C. Just copy paste this. So here we will write B for each. And this will be C. So what is the meaning of this? Based on our value in the data register and the current value of counter, instruction will compare. And if data register, yeah, let us use D100, from D100. You can use any data register, but in HMI we are going to use recipe control program. So it will use some data register from D0 to D5 to D6. So besides that, you can use any data register. You can write from D10 also, or D50 or D100. So let us say for simplicity, we are using 18 registers from D100. Why 18 registers? So let me show you. In the first, we will write the first on time for material A. Okay. Similarly, in the second data register, we will write first off time for material A. Similarly, in the third data register, we will write second on time for material A, and here we will write second off time for material A. And similarly, here we will use third on time for material A, third off time for material A. For example, here I am writing in this data register, I will write one time, okay, and here also I will write one time. So during this period, what will happen? Our M0 will be on. Then what will happen? This D102 to D103, M1 will open, and during this time M2 will be operated. So in this way, for material A, we are using 6 data registers. So from 106 to 11, another 6 registers for material B, and then another 6 registers for material C. So in this way, we are going to use 18 data registers. Okay. So I am not writing comment for each and every one because that is not going to be visible in our ladder programming. So no need to do this. This is just for your explanation that why we will use 18 data registers and how I have written all this. Okay. So this is all for our comments, and we have used one counter C0. So just write C0 over here. So now let us go and start our programming. So click over programs, right click and click on the new and just click OK. So let me maximize this, zoom it so it is visible properly. So as you know, first 3 networks was the starting. When the starting command is there, mixing motor should be operated. So here I will write mixing motor on logic. Press enter and just select contact. Bring your cursor to red portion. Select output coil and write address for each element. X0, press enter, and this will be our Y0. Press enter. So if the process is on, mixing motor should start. Okay. After that, what was the another step in our logic table? Again, I will write, we have to give 1 second pulse to our counter. So here I will write, give 1 second pulse to counter and press enter. So again, take contact, bring your cursor to this red portion, write its address X0. The process is on. Then we have to give pulses. But how we will give pulses? So again, select the contact and bring your cursor to this red portion and write its address M1013. So this is the special internal register of Delta PLC. You can see 1 second clock pulse. So by default in the Delta PLC, this bit is giving 1 second pulse. Okay. Now here we have to connect our counter. So go to functions block, select all types and write over here CNT, that is the mnemonics for counter, insert it. So first of all, we have to write the counter number C0, and here we have to write the preset value. So as discussed in the logic, we have taken 60 seconds as our one batch completing time. So here I will write 60. Okay. Again, insert a network. What was our third step in the logic table? That we have to start our ABSD instruction. So here I will write start ABSD instruction. This is the absolute drum sequence instruction. So again, take a contact from here. If the process is on, that means X0 over here, press enter. Now here we have to write this ABSD instruction. So for that, again go to functions from here, select all types, and here you have to write ABSD. This is the mnemonics for this instruction, and you can see this block is inserted. So in the S1, here we have to write the address from where our data or the parameter is starting. So as discussed earlier, I am going to use 18 data registers starting from D100 for the recipe parameters. Okay. So by HMI, we will write 18 values in 18 data registers starting from D100. If we are not using HMI, then how you can enter this data? So simply insert a network, and here we have to write move instruction, like you want to move 15 in data register D100, press enter. So you can see in this way you can move data in this 18 register. Similarly, you have to write for D101, D102, D103 up to D117. So this thing we don't have to do manually. That's why I'm doing this through HMI. So just delete this. If you are not using HMI, then you can do this thing to write data in this D100 to D18 register. So let us just delete this. This was just for your explanation. Now here we have to write what we are going to compare. So I am going to compare the value of counter. With each second, the value of counter will increase. So it is just like a 60-second timer. Okay. This is just comparing the current time with the timing given in the data register. We have to write how many internal relays we will use. So we are going to use 9 relays and starting from M0. Okay. So this is our ABSD instruction. Now insert a network. We have to write reset logic for this. Okay, so I will write reset. So when the one batch processing is completed, so counting is completed, so C0 bit will become on, and after that nothing will happen. So we have to make C0 0 to start the process from beginning. So for that we have to reset the counter. Over here we have used X1 button, that is our reset button, to reset our counter C0. So for that, double click over here and select reset. So if this button is pressed, counter will be resetted and process will start from beginning. Now again insert a network. So this is logic for solenoid valve 1. Press enter. So as discussed earlier, we are going to use 3 internal relays. If either of 3 internal relays is on, then our solenoid valve 1 should become on. So what are these 3 internal relays? That are nothing but M0, M1 and M2. This is our Y1. That is our first solenoid valve. So in same way, we will write logic for solenoid valve 2 and solenoid valve 3. So insert 2 networks for each, and here we will write SV2. Press enter. Again insert 3 parallel contacts. To use parallel contacts, and again on one output coil. Similarly over here, insert 3 parallel contacts, one output coil, and delete this network. So right over here, M3, M4 and M5. So from network comments also you can see that this is the first time when B becomes on, this is the second time when B becomes on, this is the third time. Similarly over here, M6, M7 and M8. And here we will write Y3 for solenoid valve 3. So this is our complete ladder programming for recipe control using PLC and HMI. It's simulation and HMI designing that we will see in the next part of this video, because this tutorial already have become lengthy. So meet you in the next part of this video. If you want to learn more examples like this, stay tuned to our YouTube channel. Show your interest by liking and subscribing